Hello, my name is John Sloan. I'm the Executive Vice President for Not So Secure USA. I want to thank you for joining this exciting and extremely informative webinar, Through an Attacker's Eyes, Your Web Applications. Before we get into the heart of the presentation, I want to first highlight a little bit about who we are. Not So Secure is an intricate part of our Clarinet cybersecurity practice. Clarinet, our parent company, is one of the largest managed service providers in Europe and abroad, focused on modernizing and running critical applications and infrastructure 24/7 for our customers. The Clarinet cybersecurity practice has over 20 years of experience in cybersecurity services and training for some of the biggest brands across the globe. We are one of the largest training partners of the globally acclaimed Black Hat conferences, where we train hundreds of participants in cybersecurity every year. What differentiates us from our competitors in cybersecurity is we hack and we teach. Our teachers are our hackers, enabling us to provide the most researched and capable penetration testers in the market. As teachers, our hacker training program encompasses training that supports beginners, which are individuals with little to no security experience, all the way up to advanced, to include advanced infrastructure hacking and advanced web hacking. We also have specialized cybersecurity training focused on DevSecOps and hacking and securing cloud. This webinar is an introductory to our 5-day advanced web hacking training course. At the end of the webinar, we will provide additional information on how and where you can attend one of our advanced web hacking courses. As hackers, we provide white box and gray box penetration testing services for your business applications, infrastructure, cloud, and mobile environments. Additionally, we provide successful black box red teaming security assessments where we leverage our hacking expertise to find vulnerabilities that vulnerability scans are not able to identify. This wraps up a little bit about who we are, and now without further ado, I welcome Dhruv Shah, who's going to give us a unique hacker insight into our advanced web hacking training course. There will be a cute questions and answer session at the end of the webinar. Please feel free to submit questions via chat throughout the session. We will gather them and we will present them back during Q&A. Also, we do have a prize draw to attend our next live delivery of advanced web hacking, which I will address at the end of the webinar. Dhruv?
Thanks a lot, John. Hello guys, my name is Dhruv. I'm an Associate Director at Not So Secure. A little background about myself before we jump into what we are going to be teaching in this particular course. So I have authored 2 books, Kali Linux Intrusion and Exploitation and Hands-on Pen Testing using Burp Suite, both published by Packet Publishers. My area of expertise is mobile, web application, network security. I have delivered trainings at various different conferences, including Black Hat in USA, Asia, Chicago, Tokyo, in Hack in Paris, OWASP, AppSec, Tel Aviv, then Texas Cyber Summit, NordSec, and a lot more other conferences. Now, why are we here, or why are we sitting for this particular webinar? The idea is that most of the web applications, right, the vulnerabilities that you find on them are usually revolving around the top 10 categories of OWASP. And defenders always pay a close attention to these sort of vulnerabilities and try to patch them, and also keep an eye for all the vulnerabilities detected by automated scanners. Now, if the defenders are actively looking at vulnerabilities via automated scanners, then it becomes difficult for pen testers to find more vulnerabilities outside of the automated scan zones. And in order to be more efficient and more skilled, the attackers need to know how to do an analysis of an application and find vulnerabilities that often go undetected by automated scanners. And quite a lot of times, depending on the business logic implementations and the thought process of the attackers, it helps them succeed and find bugs on the application. Now, in this particular course, we aim to take you through some of the most interesting scenarios that we have encountered in real pen test engagements to neat and new and ridiculous web vulnerabilities that would take you in awe. Well, this is basically a plug. All the demos that I'm going to show you during this talk are from the real environment of our class, and attendees get to access all this content and practice everything in the advanced web hacking course. Now, the first question that I usually get asked is, how are the topics for this particular training selected? Are they handpicked, or is there a criteria for them? What we do is we ensure that the vulnerabilities that we try to put into this particular course are usually the ones that are not detected by automated scanners. There are also some sort of twisted bugs where chaining is required in order to exploit a particular vulnerability, and also collated a few set of famous bug bounty reports and simulated the entire environment in our labs to give you an experience of how you should perform an analysis and come across those bugs. And we have sophisticated business logic flaws and labs around it which you can experience. Now, to add to this, the course does not just provide you a particular page that says, hey, this page is vulnerable to so and so vulnerabilities. Please input this malicious payload and you'll be able to exploit it. But we give you an entire simulation of various different web applications, various real world web applications, where we also show you where you should find these particular bugs that we are talking about. Right? So without wasting further time, let's look at the course syllabus. So this is part one of the syllabus. There are 2 slides for this, and the ones which are highlighted in yellow are the ones which I'm going to give you a walkthrough around. So we have attacking authentication and single sign-on, in which we look at Saml authorization bypass. Within XXE attacks, we'll be talking about XXE and file parsing. In breaking cryptography, we'll be talking about how authentication bypass can happen if .NET machine keys are leaked. In remote code execution, we'll be talking about .NET serialization attacks. In Sql Injection, we'll be talking about how we can do Sql Injection via cryptography. And in cloud, we'll be looking at server-side exploitation leading to remote code execution in AWS environments. So let's start the first topic, that is attacking Saml auth. Whatever we will be doing from this point onwards is basically an excerpt to show you how the training progresses and how the trainers teach you during the class. So SAML is nothing but security assertion markup language. SAML is basically an authentication where there are 2 different providers, where one is the identity provider, also called as the authentication server, whereas all the other web applications are the service providers. The SAML document is basically a base64 encoded document, which is basically used to pass it to the service provider, where the service provider validates that particular document by checking the signature and ensuring that it is valid and the integrity is maintained. Now, before we jump into how SAML can be done, it is always better to understand the SAML workflow, right? So I'm going to use a laser pointer to explain the concept. Here we are the users, and the service providers are nothing but the web application, whereas the identity providers are the authentication servers. So when you are using SAML, when you visit a particular website, what the website does is the website sees whether you want to try and access a unique resource that requires authentication. And if you do, it will try to discover the identity provider in the backend, and it will tell the identity provider that, hey, I am a part of your ecosystem and I need a user to log in to my application and access a particular resource. Can you please authenticate that user and provide me the authorization details? The identity provider says, yes, you are a valid user. Can you please redirect him to the authentication page? So the user is then redirected to the identity provider page. Here, the user provides the credentials, and on successful authentication, the user is provided with an XHTML form, which is signed by a signature. This form is then redirected to the web application, where the web application validates whether the integrity is maintained of the document and the user, along with the authorization details. And then all the content that the user is allowed to access is shown to the user, right? So this is a simple, straightforward SAML workflow. Now, one of the most common attack type happens when you tamper with the response of the XHTML form. So this is a sample of how a SAML response looks like. Now, within this, the most important thing that you need to look at is the name ID parameter that contains the unique email ID, which is going to be authorized on that particular web application, right? So in this particular scenario, the user who has logged in is sunil@notsosecure.com. And this is the XHTML form that will go to the web application and authenticate this user and show the content of this particular user. One of the most common misconfigurations is where an attacker can simply change this email address to some other email ID. And if there is no proper validation at the client side or the service provider or the web application that authorizes the data, then the attacker will be able to access the content of the other malicious or the victim's email ID that the attacker has provided. So that's a simple scenario one. And obviously that's the most easiest way of SAML bypass. Well, we are not going to talk about that one. We are going to talk about a scenario where if you change this particular email ID, the application throws you an error that the signature mismatches and there's a tampering detected. How do we bypass those type of scenarios? So we'll be talking about that particular scenario. We'll be trying to exploit SAML by leveraging a canonicalization feature. Now, one might think, what exactly is a canonicalization feature? Canonicalization is a mechanism through which you can use the same document irrespective of the order of representation and still have the same signature, which is very important for web developers in order for content delivery. Like, for example, within this entire Saml request, if I say that issue instant is written after XML_NS_XS, like this particular value, as long as it is within the Saml assertion endpoint, the meaning of this document is same, just the representation order is different, right? So canonicalization ensures that it doesn't matter where the issue instant is placed within this entire box, as long as it is there and the meaning of the document is same, the signature will always be the same. And canonicalization by default ignores spaces and comments. So this is one point that we can keep in mind, that canonicalization engine ignores the spaces and comments, which simply means that if there is a comment in this particular document, it will not be considered for the signature generation. So what the attacker will do is the attacker can simply create a payload where, let's say, the valid user is not so secure user at the rate webacklab.com, and the attacker injects a comment in the email ID function itself. So here what will happen is, as soon as the user sends this data, it will first pass to the validation endpoint and it will see that, okay, not so secure, this is a comment user at the rate webacklab.com. So canonicalization says ignore the comment and then verify the signature. So the original value will be not so secure user at the rate webacklab.com, which is the original user. And it will say, yes, this is the valid user, please proceed further. When it goes to proceed further, the XML parser in the backend receives three different values: not so secure, this is a comment, and user at the rate webacklab.com. And this will allow the XML parser to end up taking the last value. XML usually takes only one value, and normally when you pass three, it will only take the last one. And the last one out here is user at the rate webacklab.com, and it will fetch you the content of user at the rate webacklab.com when you actually have the account, not so secure user at the rate webacklab.com. So I'm going to show you a quick demo around this. So if you see here, we have a simulated application top up, and here I'm going to go ahead and sign in with an account that I have. So I'll go to OneLogin and I'll provide my details. So I'll say not a John at the rate webacklab.com because John is the victim into whose account I want to log into. I'll provide a password for not a John. And then I will intercept the XHTML form in my browser, in my proxy. So I have this response. Saml is basically a base64 encoded data. So we'll simply click on the Saml tab and base64 decode the value. And if you see, the email ID is not a John at the rate webacklab.com. And when we check this, we'll keep a copy of this in the repeater because we want to play with this and see if we can find the bypass. So I'll send this request, which has not a John at the rate webacklab.com because that's the valid request. And the application responds back by saying, okay, you are the correct user. Brilliant. So now if I try to just change it to John at the rate webacklab.com, it should not work, right? Because it is validating the signature and hence it says failed. So let's look how we can do the canonicalization attack. I'll simply add a comment saying this is a comment and close the comment tag and send the request. And if you see here, it says, okay, John at the rate webacklab.com because we bypass the canonicalization implementation where it ignores the comments and spaces for signature generation mechanism. So I can simply take this request and try to replay it in the browser, and I should be logged in as John at the rate webacklab.com. So I'm just going to go ahead and paste it and try to access the application. And if you see here, I'm logged in as John at the rate webacklab.com, right? So this is the particular exercise on Saml. You get to play with these. You get ample of time during the lab to practice this exercise and do a Q&A session with the trainers to understand any other details that you need from the development perspective or from the pen test perspective as well. The next one that we are going to look at is XXE in file parsing. Now, we know what XXE is all about, right? XXE is basically vulnerabilities that you can leverage by writing doc type definitions within an XML syntax, and creating external references. Now, the important thing to understand is that all these open document formats that we use on a day-to-day basis on applications, like docx files, pptx files, xlsx files, pdf files, and all of them are nothing but members of open document format. And open document format members are nothing but a collection of XML files zipped together and given an extension name. And if you go ahead and create a doc file on your own systems and just rename it to zip and extract the contents, you will simply see that it's nothing but collection of XML documents. So this opens a very big avenue of pen test when you're doing or testing for file upload vulnerabilities. Because if an application is allowing you to upload a file and the application processes the content of the file, you can spot and identify where to perform an XXE attack. Like, here's a simple example. An attacker injects a payload in a doc file and finds out that when you upload the document, it reads the content from that endpoint. If it does, then you can actually inject your XXE payload in that particular endpoint and try to retrieve sensitive data from that vulnerable server. Here's an example of understanding how an XXE attack can take place in a file upload functionality. So I'm going to go ahead and play the video. So we have another website called as shopwebhacklab.com, which is again a simulation for a shopping website where you can simply go ahead and shop for various products. Now within this, there is a careers option where you can try to apply on this particular portal and give in your details. So I'm filling up my details, just random name, last name, and random mobile number, email ID, LinkedIn details, and I'm going to upload my resume. So I'll simply say this is my resume and click on open and submit this data. It says the data has been uploaded successfully. And if you look at the top left in the web application browser, it says title, my title has been added. Let's look at it. What is this? So let's go to the burp proxy and check what exactly was shown. So we'll go to the history and we'll just check out the previous request and we'll try to identify what was the response. It says title, my title has been added. But when we look at the document, there is no word in the document that reads my title, which means it has taken something from the metadata information. Now, in order to identify from which metadata information it has taken place, I will open the docx file in a VI editor, which will open the zip and show me all the XML files below it. So if you see, these are all the different XML files. Now, the file from where we got the data is from the core.xml file where the highlight is given. So when you proceed further, you will see that there is a DC title, my title node within that XML document. So this is the place from where the application retrieved the content, my title, and showed it to me on the screen. So as an attacker, I can simply go ahead and inject an XXE payload in this particular document and try to see if the parser is weakly configured to extract and allow me to see the contents of the files that I want to access. So we'll go ahead and check it out. I have created another document called as resume2.docx. Within the core.xml file, I have injected the payload already. So if you see, it's a simple XML declaration where an XXE variable contains the content of etc parse wd, and within the DC title parameter, I am fetching the variable contents of XXE. Right? So let's go ahead and try to upload this particular document. So I'm just going to close this. And I'm going to go ahead and upload the document again. So I'll go to the career option, first name, last name, mobile number. I'll upload the resume2.docx file and I will try to upload the document again to see if I'm able to perform the XXE attack. Now, if you see in the backend, it fetched us the content of etc parse wd, which means that the application parser is weakly configured and we are able to read contents from the file. Right? If you go to the burp logs and try to check it again, you'll be able to see the response contains the content of etc parse wd. And as an attacker, what we usually do is we try to find config files because they contain passwords that allow you to further navigate within the application or even within the network, right? So this is how you can perform an XXE attack in file upload functionalities. The next one is a .NET machine key bypass. Now this is a very interesting one, and I'm sure you guys are going to love it. Now, first, let us understand what machine keys are. Machine keys are basically used for the encryption and decryption of form authentications, cookie data, view state data, and a lot of other endpoints that are used for encrypting in .NET frameworks. Machine keys are usually configured within the web.config file, and they look like something as you can see here, right? So I'm just going to use a highlighter, something that you see here. It contains a validation key, that is the key that you want to use for validation purposes, the decryption key that you want to use, and the validation algorithm and the decryption algorithm. Now, what all is encrypted using a machine key? You can encrypt forms, ASP.NET cookies, view state, webresource.ext, CSRF tokens, password reset tokens, and many other functionalities in .NET. Now, why are we talking about this particular endpoint? So the problem exists in the way people approach into solving their issues while they're developing a web application. Let's say a developer created a web application in .NET and the application is working flawlessly. Now, because the owner has to scale because of high demand or the application is catching up, they need to deploy this entire application under a web farm, which basically means you need to deploy a lot of different servers having the same application and all of them controlled by a load balancer. Now, in that case, if the developer simply goes and creates all the applications and puts them behind load balancer, it will not work. It will throw some weird sort of errors. And on doing a quick Google, if the developer relies on Microsoft documentation itself, they will land on this particular page. Now, if you carefully read what is written on the Microsoft documentation itself, it says, if the scenario involves a web farm, the machine keys should be same across everywhere. Use the below machine key to maintain the consistency on all the servers on the farm. So the developer simply takes this machine key and pastes it in all the web servers and then tries to check the application and it's working perfectly, and now it's gone to production. The problem is that they don't know that if an attacker copies this key, they can do a lot more damage to their application. Let's say that they did not go to the Microsoft documentation, right? They go to their favorite endpoint, Stack Overflow. Even in Stack Overflow, there are people who come forward and say that, hey, if you're facing a problem, you should use something like this, which I have in my environment. You can use this validation key, decryption key, specify the validation algorithm and decryption algorithm and use it. And there are so many people who have upvoted as well. If not, go to GitHub. You'll see almost 200,000 results where machine keys are exposed, and you can go ahead and find their live applications and perform these exploits that I'm just going to show you. Right, so let's check this out. I'm going to play this video. So we'll go to another application which is called as admin.webhacklab.com, which is a backend for the application topup.webhacklab.com in our environment. Now we'll simply turn on the intercept and just try to identify if it contains a ASPX auth cookie. Now if you see there's an ASPX auth cookie that is available. So this ASPX auth cookie is generated with the help of machine keys, and there is a machine key that is configured on that particular server which the attacker has no idea of. So we'll copy this machine key, and what we'll do is we'll go ahead and we'll try to play with this. So we'll send a copy of this to repeater first, and we'll go to a utility called as Blacklister. All right, so let me just load Blacklister. I'll shortly explain what Blacklister is all about. So Blacklister is basically a tool that we at NSS have released and made it open source, and you can access our GitHub profile, Not So Secure, and download Blacklister. What Blacklister does is, Blacklister is basically a project that we have done to accumulate all the publicly exposed machine keys, be it on GitHub, be it on Stack Overflow, be it on Microsoft documentation, that allows us to decrypt sensitive data of applications such as ASPX auth. What can we do with that? Let's check this out. So I'll go to the Blacklister utility and I'll put the ASPX auth cookie. And I will simply say that the purpose is ASPX auth and the default algorithm and the decryption algorithm is SHA1 and AES. I'll click on decrypt. And what this tool will do is this tool will try this ASPX auth cookie and try to decode this cookie using all the machine keys that we have. And even if one succeeds, it goes ahead and says, hey, I was able to decrypt this, and this is the decrypted data. So if you scroll down, it says that the user data is anonymous and the username is anonymous because it's an anonymous user who's accessed the application. All right. Now, because you have the machine key now, you can actually edit the data. Let's try anonymous. Doesn't really work. Let's try some valid user, administrator and spam administrator. That doesn't work either. Admin, well, the application ended up giving you a user enumeration endpoint that is invalid password, which means that the user admin exists. Now, why are we doing this activity? We are doing this because if you are going to create an authenticated cookie of a user, you need to know the username, right? So here you found out that the valid user on this application is admin. There are many other tricks through which you can identify valid users on an application, this being one of them. So let's go ahead and try to create a valid cookie for an admin user using the blacklister utility. And before that, we'll also have to find out which page requires authentication, right? So in .NET, if you access a page that does not require authentication, it will probably show the page to you, or it will probably give you a 404 if it doesn't exist, and it will redirect you to the login page if the page exists, right? So if you see here, the account login page was being redirected when you try to access the home about page. So the home about page is the page that requires authentication, and the admin is a valid user. How can we use this information? So I'll edit the cookie and I'll say that the user is admin, the username is admin, and please can you create an encrypted cookie for me and process it. So it will go ahead and give you the encrypted cookie for that, and you can replace this in the ASPX auth endpoint by accessing a page that requires authentication, that is the home/about page in this particular utility. So let's capture the request and replace the ASPX auth cookie with the new one that we have found and see what we can check on the application. As you can see, I have accessed the admin page even without trying to pen test the application because the developer might have faced that issue because they had a web form and they copy pasted a key that was exposed on the internet. So even without pen testing, I could simply go ahead and exploit the scenario and take control of an admin account. These sort of vulnerabilities are something that no automated scanners will ever be able to find. The only way to do this is to know that these types of attacks exist, and is by updating your skill sets. Right. So the next one that we'll be looking at is insecure deserialization in .NET. We all know what data serialization is, right? We all know the textbook definition. Serialization is a simple concept where you convert a basic set of data or object into a stream of bytes, and you store it either in the file memory, in the database, or send it over the network to another endpoint where it is deserialized and it is converted back into the object. But pen testers often fail to understand why is this even used. So the best way to understand the concept of serialization is to take into consideration a simple online game. Let's say people love to play FIFA, right? So there are two people sitting in different countries playing a game against each other. Now, let's say one person selects a particular player in his team who has the football and kicks the ball few steps forward, few steps to the right, and passes it to another player who then tries to kick it a few yards forward. Now, all these different steps that I told you, selecting a player, moving the ball few steps forward, few steps right, passing it to another player, and the other player kicking the ball a few yards forward, all of these are for an object, which gets converted into a stream of bytes, which is sent over to the other person on the other corner of the world, where these stream of bytes are converted back into the object. And the object is basically read one after the other. Like the player is selected, the ball is kicked few steps forward, few steps to the right, passed on to another player, and then kicked forward. And that's why you need serialization and deserialization. So deserialization is basically used because you have no idea what is going to be sent on that particular endpoint, but it needs to be processed. Like it could have been some other player, it could have been few steps backwards, or maybe not passing to the player at all, or someone else just dribbled that player and now has the ball. So deserialization endpoint accepts any method as long as that method exists on that particular framework or on that particular application. So what happens in .NET? Now, serialization exists in a lot of them. You have Java, PHP, .NET, COM, Ruby, Python, and all other OOP languages. And all of them have had deserialization vulnerabilities that result into remote code execution. And in this course of AWH, we teach you Java, PHP, .NET, Python, and many different variances of Java, and also a few interesting ones where even after performing deserialization attacks using the open source available gadget chains, you still come to an error situation. So here we show you how you can recompile those applications or recompile those scripts in order to do certain attacks. And if you see, there's a big list of deserialization vulnerabilities that are there since 2016 onwards. And what we're going to be looking at is .NET. So the .NET framework has multiple serialization types, and the top serialization methods are binary, XML, and data contract. Now we'll be just looking at one, that is binary serialization, also known as runtime serialization. In .NET framework, binary formatter class, which is used for the concept of serializing and deserializing data, is amongst the oldest serialization concepts, and it has been widely used by many organizations, and it is accepted since it's the first serialization class available in .NET. It's lightweight, fast, and it is a very good deserializer. Now, system.runtime.serialization.binary.binary formatter is the class that performs the serialization and deserialization concepts. Now, to identify a binary serialized data in .NET, you always are supposed to keep an active eye in the HTTP request or response that you receive on a web application. If you ever see something that looks like AAEA followed by a few slashes, then it is 100% binary serialized data on .NET. And this you can exploit because .NET documentation or the Microsoft have gone forward and confessed that the way that this particular binary formatter has been implemented for the day-to-day use of serializing and deserializing, they did not take into consideration that RCE could be possible. And there is no way for them to fix it, which basically means that if any organization is using binary formatter class, they are vulnerable to remote code execution because even the owners of this particular library have said that they cannot fix it. So Serial is a utility that is contributed by a lot of different security researchers who have found bugs in these .NET deserialization environments. So we'll be using Serial.net to understand how this attack particularly works, right? So I'm just going to go ahead and play this video to show you this particular exercise. All right, so I'm just going to turn on the intercept and I'm going to capture this NSS temp. If you see, the NSS temp contains a signature called as AAEAAD followed by a few slashes, which means that this is a .NET binary serialized data. If I try to take the content and just maybe play with it, let's just move it to repeater first. All right, I'm just going to turn off the intercept and I'm going to go ahead to the utility endpoint and use the Serial.net. So what we have done is, because our environment, we understand that people might be using MacBooks, Linux machines, or Windows systems. But for those who don't have executable access, we've hosted an application in our internal environment, which you can use to create all these payloads. And also, we've gone ahead and created an open source application where you can use all the Serial tools in a single web application, right? If you want to download that, you can again go to our Not So Secure's GitHub repository and download the Serial application or the deserialization application, right? So coming back to this, so we'll use the gadget called as type confused delegate, and a binary formatter is binary. The binary formatter is the deserialization gadget chain that you want to use. And you simply want to execute the command PowerShell.exe to send a web request to an attacker-controlled server where the attacker's IP address is 192.168.4.10, right? So here my IP address in the lab is 192.168.4.10, and I want it to connect on port number 8888 with the environment variable. The environment variable, which is username. So as soon as this executes in a PowerShell, it will fetch the environment variable username and attach it to the request. So I'll say, hey, can you please go ahead and generate the payload? The payload is generated, and I can simply copy this. And first, let me start a simple Python server. So I'll just start a server on port number 8888. And I will add the payload in the endpoint. So I paste my payload here. I ensure the payload is pasted correctly. And if you see here, I have an out-of-band request from that server where PowerShell executed and told me the user that was running this particular command, right? So this is what happens in .NET Deserialization. You can have straightforward remote code execution because there is no patch for these sort of vulnerabilities. And you get to practice all these in our lab. Let's talk about SQL injection via cryptography. So SQL injection, like we all know where cryptography is required, right? All the third-party interactions that are required. For example, let's say you are an e-commerce application and you need to communicate with the payment gateway. In order to communicate with the payment gateway, you need to send sensitive information, and this sensitive information needs to be encrypted some way or the other, which means start using encryption keys. So let's say the organization started using a symmetric key between the e-commerce application and the payment gateway. So all the sensitive data is encrypted, or maybe there are some sensitive information within their application which they need to encrypt, and they have the key for it. Now the problem is, when you're pen testing an application, you're usually bound by time, right? You either have a pen test that is for 4 days or 5 days, and if you're doing bug bounty, you have a lot of time. But in these scenarios, pen testers often miss out pen testing encrypted endpoints because it requires a lot of effort. Now, what we want to show you is you should always keep a list of all the endpoints that accept encrypted parameters, because you never know that if an encryption endpoint is exposed, the attacker can still craft payloads and leverage or pen test the endpoints or the parameters that accept encrypted values. Like for example, when you look at a payment process, right? You initiate your payment process and there's a credit card number, CVV number, phone number, address, etc., which is passed to the e-commerce backend. Now the e-commerce backend takes all this data, encrypts it, and then redirects the data back to you and tells you, can you take this encrypted data and go to the payment gateway? And you do that religiously. But if you wanted to test the payment gateway for vulnerabilities, what can you do? You cannot do anything unless and until you know the encryption key. And to be honest, there is no way to find an encryption key unless and until you find remote code execution. However, often due to misconfigurations, developers end up using the same key inside the application to use some or the other functionality. And if you find some endpoints like these that accept clear text input and give you encrypted outputs in return, you can pen test the payment gateway as well. So we'll be looking at that sort of scenarios, but we will also be showing you something about blind injections, right? So in certain cases, to add to the complexity of this particular vulnerability where we try to do SQL injection via crypto, we'll try to do SQL injection via cryptography over a blind SQL injection vulnerability. Now in SQL injection, when you're trying to validate blind SQL injections, you have a lot of different functionalities within SQL, right? Because SQLs are nothing but SQL platforms and they have a lot of functions and stored procedures. Like for example, one such stored procedure is master.sys.xpdir tree in MS SQL servers. These can be used for generating out-of-band requests because the purpose of xpdir tree is to basically list files and directories from a local or an external IP address. So we'll be looking at how to craft the payloads and how to send the attack, right? So let me show you a demo how SQL injection through cryptography takes place. So I'll go to the top-up application, and this is a normal simulation. So let's say I select Vodafone top-up, right? So I want to go ahead and take this top-up, and there is an apply coupon functionality on this application. It says apply and you can get up to 80% discount. And we even pen test this coupon endpoint, right, during the course to see how you can bypass coupon functionalities as well. But coming here, sticking to the point, Sql injection and cryptography. Here, we simply send a simple value, which is an invalid coupon, but just want to understand what is the response shown in return, right? So I'm just going to turn on the responses and check. I click on apply. There is a coupon code, a PID parameter, and a signature parameter that protects this coupon code from being bypassed, right? But we have also another exercise in the course that shows you how you can bypass signatures as well. So let's say the user entered test123 as the coupon code and sent that request to the server. The response in return is something that is base64 encoded, and the rest says that it is an invalid code. Now, why was this base64 encoded in the first place? Let's try to decode this component and understand what it really means. On decoding, it was an encrypted value, which means that that's an endpoint that's accepting clear text information and giving me an encrypted base64 value. So encrypted value, which is base64 encoded. So let's just complete a payment. We made a note of this information and we're just trying to pen test this particular endpoint. So obviously we have a payment gateway, but we accept dummy card details and just basically to test payment gateway vulnerabilities as well. So here, good job, payment is processed. And once the payment is completed, what happens is the application sends an email saying successful payment received and order confirmed. Now, the reason why we are showing you this as well is because there are times when automated scanners will not find all the links that are available on the application. There are certain links that will be generated only after completing a particular process. So here, after completing a particular process of payment, there is a new link that is generated, which is found here when you click on View Now. So we click on View Now, and the first request that is generated is shop order transaction ID equals to an encrypted value. So we'll keep a copy of this in the repeater for future reference. We'll forward this data. Response to it, okay. There's an API request that again fetches transaction ID is equals to encrypted data. Interesting, endpoint number 2. All right. Now what I'll do is I'll go back to the coupon feature and I will try to inject a SQL command, a simple sleep command to see if the database goes to sleep for 10 seconds. So I'll say single quote, wait for delay, single quote, and make it go to sleep for probably 10 seconds or 5 seconds. Yeah. And click on apply and capture the encrypted value that I was seeing, right? So I'll just go back to my history logs and I'll try to fetch that value out. So this was the request that we sent, wait for delay for 5 seconds, and the response was, this is the code that I have. So I'll simply take this encrypted value and try it in both these endpoints where we saw encrypted data. So I'll go to repeater, go in the first one, and remove this encrypted value and paste my encrypted payload and hit forward. Nothing happened, right? So maybe it has a filter or maybe it's safe. Let's try the second one. I paste my payload and I click on send. And if you see, it's gone in the waiting state and responds exactly after 5 seconds. So if you see here, 5,162 milliseconds. So this tells us that this particular endpoint is vulnerable to SQL injection. Now what I'm going to do is we're going to actually see how you can perform out-of-band vulnerabilities without relying on tools like Verb Collaborator. Right? Verb Collaborator is something that is used on a professional edition if you have a license. What if you don't? So in this environment, what we have done is we've configured our environment in a way where you can tap on your DNS server with the UDP protocol and capture out-of-bound requests. So here TCP dump-n UDP protocol port number 53, listen to all the interfaces and have a listener running. Now I'll go ahead and create a unique subdomain name and try to fetch an out-of-band call. So since I am user 10, my unique subdomain name will be something that is related to user10.webacclab.com, in this particular lab, right? So let me just quickly go ahead and create a payload. So exec master xp dir tree user10.webhacklab.com. Now, since user10.webhacklab.com does not exist in the DNS servers, it will send an out-of-band call to the owner as to where this particular endpoint is located. So let's capture the encrypted value to try and execute the xpdir tree payload of MS SQL. And I'm going to paste it here. And as soon as the xpdir tree executes, I should have an out-of-band call. So you see, I got an out-of-band call and the application is vulnerable to a blind Sql injection via a cryptographic parameter that's pretty complex, which an automated tool can never find. So these are the different types of attacks that we have. And with that, we come to cloud attacks, SSRF exploitation. We'll talk about how SSRF vulnerabilities in AWS can result into remote code executions as well. Now, the first thing to understand is, why are people going to cloud too much? And what is the key premise of cloud computing? So the first thing that you need to understand is that it is a shared pool of configurable system resources and it is decentralized, which helps a lot of organizations. It has rapid provisioning, so it saves you a lot of time and it allows you remote access. Whereas in data centers, you do not get remote access easily. You have to physically go there to the data centers and configure whatever changes you need to make. There's minimum management required in cloud computing and there's reduced IT hardware cost. And it is pretty flexible and scalable. Now, why do we need cloud security? The reason we need cloud security is because major organizations are moving to cloud without knowing what sort of service do they require. And because there is cloud services, one thing to remember is that it has a shared infrastructure model, which is protected by virtualization. It has multitude of offerings. You have different threat models, which means different threat models equals to different test cases, which equals to different types of vulnerabilities. If you end up taking a wrong offering and perform a wrong operation, you're exposing your environment to other set of vulnerabilities that you did not anticipate. For example, if you just want to manage a web application, why purchase an entire Windows server or a Linux server and host a web server on it and host a web application on top of it? The owner will then have to take care of the operating system updates and many other updates as well. An attack in cloud security environments will not only lead to leakage of data, but it will also lead to loss of monetary loss and unauthorized softwares running in your environment, leading to an additional money being piled up. One of the biggest example is code spaces. We talk about code spaces in our course. Long story short, code spaces accidentally, one of their keys, a high privileged keys, was leaked on the internet, and an attacker basically blackmailed them, and on failing to do so or failing to get the money, the attacker simply deleted the entire organization from the cloud environment. And code spaces did not have their own data, did not have their client data, and they had to shut down their business in a day. So cloud security is very, very, very important. Now, in this particular AWH course, we usually talk about advanced web hacking related vulnerabilities in cloud. We have another course that is hacking and securing cloud that teaches you in detail all the other components of cloud security as well. So if you look at the cloud responsibility matrix, you have on-premises, infrastructure as a service, platform as a service, function as a service, and software as a service. And there are various responsibilities. And the responsibilities become less and less for the owner as and when you keep taking the better services provided by the cloud providers, right? So if you have on-premises, everything is your responsibility, right from physical security to client side. But if you're using software as a service, all the application level functions are managed by the cloud service providers. You only need to manage the data and things on the client side. So always be cautious while you're selecting the service that you need for a particular work. Now, what attackers usually look for in cloud environments? Attackers usually look for something called as metadata API. Metadata APIs are nothing but APIs that allow you to check for the health and the functioning of your existing environment instances. Like in AWS, you can call 169.254.169.254. It's a non-routable IP address that gives you the configuration details, monitoring details, and a lot more. Similarly, Google and Azure also have non-routable IP addresses which they can query to check instance health. Now, why are we talking about this? Reason being that if there are applications which are vulnerable to SSRF in various environments, attackers can access these non-routable IP addresses. These IP addresses can only be queried from within the machine that you own, which means that if you don't own a machine, there is no metadata API you can access. And the only way to access these non-routable IP address is if the application is vulnerable to SSRF, since the application will generate a request to this IP address on behalf of you. So who is vulnerable to SSRF? Well, if the application is hosted on AWS and using the IMDS1, then the attacker can basically identity management version 1. The attacker can simply access the non-routable IP address and get all the data. But if they're using 2, then they are safe. And most of the organizations still are found to be using the vulnerable identity management mechanisms. In GCP, V1 Beta 1 has been discontinued, so V1 GCP is protected against SSRF attacks. The new one that they're using is a custom HTTP header called as Flavor Google V1. And Azure already had a custom header called as metadata true, so they are safe. And if the application is vulnerable to remote code execution on a cloud environment, then anyone on any particular cloud service providers, they can access this data easily. So what we are going to do is we're going to look at a case study of something that happened in a real world scenario where there was an application that was vulnerable to SSRF, and that application was a very default configured application by a web developer. So the web developer basically created an account, hosted an application, and understanding the DevOps pipeline also created a staging and production environment. And this is what happens if people with no knowledge of cloud security host applications. So let's have a look at this particular attack, that is cloud attack, which is probably the last one. So here this particular application, cloud.webappLab.com, has a doc parameter on the view post document page.php, which is vulnerable to SSRF, right? So the page is view post document.php. Keep the page name in mind. So first we try to validate whether the doc parameter is vulnerable. So in order to check, we can always check the server status page in PHP environment because it's usually Apache servers, and server status page are not allowed to be accessed directly from the public environment. You can only query it from the localhost. So here it says forbidden, you do not have access to this particular page. I'll copy a request out here. I'll send this to repeater and we'll check it out here. So what I'll do is I'll simply say localhost and show me the server status page. And I'm able to see it, right? Now I'll try to access the non-routable IP address 169.254.169.254 and see if I'm able to query the metadata APIs. The attacker is able to query. So I'll go to the latest API, which contains metadata. I'll access the metadata field and IAM. Now I'm going to access IAM and I'm going to pause the screen a bit. IAM stands for Identity and Access Management. Now this identity and access management contains temporary credentials which allow the application to communicate with other applications using having the same permissions, right? So let's say there's an EC2 instance which has an identity and access management token. That same token will have some sort of permissions which are configured for an S3 bucket where you can store the data. So if the attacker gets hold of these IAM credentials, this is what happens. So IAM credentials, security credentials, and this is the default EC2 instance role that gets created. These are the temporary credentials that I have, and we're going to keep a copy of it, or we'll simply just configure it. So I'll paste this data here, and I'll go ahead and configure my AWS CLI. Now, one thing that was missing is the region. So to check the region, I can simply go to another API, which is in dynamic. And within dynamic, I'll simply access instance identity. Let me just add the slash. And I'll access the document. And within the document, the region that says is that it's hosted in US East 1. So let's go ahead and configure the AWS CLI. I'll just configure a few variables on my Linux environment itself. So I'll configure the AWS access key. Then I'll configure my secret access key. then I'll go ahead and add the token as well. And after I've given the token, I also need to specify the region where these keys are applicable, right? So I'll first paste the token, and then I'll specify the region where these tokens are to be checked. So I'll say AWS default region is equals to US East 1. To validate whether my credentials are correct, I will have to run the command AWS secret token service get the caller's identity, where it will verify whether these credentials are correct or not. And on running so, it will check and say, yes, you are a valid user, this is your account, and this is your Amazon resource name. I try to list the buckets by giving the command AWS S3LS. The output we get is access denied. Now, this is the problem where pen testers usually give up. So the thing is, if you read the documentation of AWS on what happens when you create an EC2 instance, they say that they create special S3 buckets where storage is taken care of. And this special S3 buckets that are created are mapped to your Elastic Beanstalk instance, and they cannot be directly called via AWS S3LS. Now, no automated tool is going to find this for you. But in order to do that, you'll simply say AWS S3LS, and this is the naming mechanism. You'll say S3:// Beanstalk, followed by the region, followed by the account number. So I'll give the account number and I'll hit enter, and it should be able to show me what is the content in that storage bucket. So there's a staging zip file that I can see. So what I'll do is I'll just create a document. Let me create one folder, SSRF test. And I'm just going to go inside it and download this particular endpoint. So instead of saying S3LS, I'll simply say S3 copy and download it in the current folder by giving a dot and -- recursive to download everything. So we'll wait a bit for it to download. It should be probably within 10 seconds. If you see, it's downloading a lot of stuff and it reads code pipeline. I see a lot of code pipeline written above. Now let's open this particular zip file, and if you see, it's the view post document.php. The application that we saw is also view post document.php, which means we have probably hit a staging server of this particular environment where the IAM keys are available for the staging environment as well. So I'll simply copy a PHP web shell into this particular folder and push it inside the zip file and re-upload the file in the staging server. So I'll say zip-ur, append that web shell, and upload the folder, the zip file, back to the S3. So copy this file back to the S3 and enter. Now once it is uploaded, let's see what happens. So in the backend, what would happen is the CI/CD pipeline would execute, and the staging server would try to go ahead and take that zip file and push it to the production environment, right? So we can keep trying. We never know what is the time that it takes for it to push from staging to production. It could either be 5 minutes, it could be 15 minutes, or it could even be a day, or it could be instantaneous within 5 seconds. But as soon as the staging to production happens, this is what you can do. You'll be able to access the web shell and you can do remote code execution, right? So this is what cloud exploitation looks like. And this is what happens if organizations host applications without taking into consideration the security prospects of things, right? So these are the few set of demonstrations that we do in our course, and we let all the attendees play with these environments, and there are a lot more topics to cover. What we have covered is probably maybe 5% of the entire course, right? So I hope you enjoyed this particular webinar. I'm going to hand it over to John to take it over and continue with the promotional videos.
Thank you, Drew. Before we get into Q&A, as previously mentioned, this webinar is a precursor to our advanced web hacking training course. These next few slides provide a list of our upcoming remote training courses and informative webinars. As we talked about in the beginning, as a special bonus for attending this webinar, just by speaking to one of our team members about your training or pen test requirements, you can become eligible to win a free place on our next live remote delivery advanced web hacking training course. To arrange your call and to gain entry to the prize draw, please email us at contact@notsosecure.com. Again, that's contact@notsosecure.com. And just a quick reminder, we hack, we teach. We'd love for the opportunity to train you, your organization, as well as provide risk assessments. So at this time, I'm going to hand it over to Ryan for some quick Q&A. Ryan?
Yeah, thank you, John, and thank you, Drew, for the presentation. I found it very interesting myself. I'm hoping that everyone else felt the same. We've had a couple of questions, and if you just have a couple of quick Q&A. So if you ever get any questions, either drop them into the question bar on your side, or you can email. There's an email address will be at the end. You can email in there and someone will get back to you. So the first question we've got, Drew, is do we get access to this lab after the training is completed?
Yes, so once you register to this course, we give a complimentary 30-day lab time after the course is completed. So you can take it at your own pace. We give you the answer sheets, the slide decks, and all the content that we teach you, which you can practice during the 30-day lab time. And you also get support from the trainers and the support staff during these 30 days as well.
All right, brilliant. We've got just two more, I believe. Another one is, do we get to practice everything shown? Do we get to practice everything shown in the training?
Yes, every topic, irrespective of it being a demo or an exercise, you will be available, or you will get to practice all of them, because they are all a part of this entire VPN that we have created, which contains all these simulated environments. Yes.
Right, perfect, thank you. And the final question we've got is there something unique about your training as compared to the findings of an automated scanner?
So as you see in all these different exercises that we did, automated scanners will never be able to reach to this point, because it requires some sort of a skill set where you have to tweak certain values in order to reach to a particular output, right? And it is not a direct approach. You'll have to find out a set of weak strings, leverage these weak strings to attack the endpoint, which is more complex in nature. And these sort of things will not be found by automated scanners. That's one of the core focus of our class.
Great, thank you for that, Drew. So that is all the questions we've had in today. I just want to say a big thank you to everyone who's joined and for getting involved in asking the questions, and I hope you enjoyed the webinar today as much as I have. At the end of this, we do have a quick survey at the end, which we'll be delighted if you could fill out. It's only take you a minute or so. It's just a couple of questions about the webinar today itself, and there's a prize draw as well, so if you're interested in speaking to us. And yeah, so thanks again. I just want to say thanks to Drew for the presentation, and thanks for John for helping out as well. I thoroughly enjoyed it, and I hope everyone has a good rest of the week wherever you are in the world. And so just the slide at the bottom here, the training at notsosecure.com. If you have any questions, comments, feedback, anything like that, please feel free to email this and someone will get back to you. So thank you for that again, everyone. And wherever you are in the world, I hope you have a good rest of the week and you've really enjoyed the webinar. Thank you.